Hey guys, this is Adam. Let's talk about performing secure authentication to other Azure services while maintaining no credentials within your code. This is a quick introduction to a great feature of Azure Active Directory called Managed Identities. Stay tuned! To better understand Managed Identities, let's talk about a few classical scenarios of how we're performing authentication in most Azure services. And for this first scenario, let's look at using keys for authentication. In this scenario, we have two services communicating with each other. Service A is a client sending a key to Service B. Service B validates the key, checks what are the permissions, and authorizes this key to perform an operation and returns the result. That's fairly simple, but as you can imagine, this imposes some challenges. First of all, managing the keys. So all the operations are on creating, revoking, rotating those keys, creating fine-grained permissions, and most of all, storing those within your application code, which imposes the highest security risk, because usually those keys are stored within your service configuration or application configuration files. And while you can move the key out of the configuration file into external servers like Azure Key Vault, which of course you should do, but again, that will leave you with a challenge of how you can securely connect to Key Vault without maintaining any keys, any credentials within your code. In this example, you're only exposed to steps 1 and 3, so you're sending the key and retrieving the result. And the key verification is handled by the second service, the service that you're connecting to. Which brings us to the second case, using Azure Active Directory for authentication across two services. Similarly, in this example, we're using two services to connect to each other, but we're also introducing Azure Active Directory, so that Service A actually sends identity credentials to Azure AD, and once those credentials are validated, a token is returned to the service that we want to connect to, so that Service A sends this token to Service B, who will connect to Azure AD to get something called OpenID configuration to verify the token. Once the token verification and all the authorization layers are verified, then the result is returned from Service B to Service A. And this provides much better security than the first example because Azure AD has a bunch of features around security and smart alerting. But we're still left with one challenge here, because we need to store this identity credentials somewhere, and they are either present within application code, application configuration file, or on the service itself. While in this flow we're only exposed to 4 steps, so we only need to send credentials to get the token and then send that token to Service B to get much better security, we're still not in the clear. We need to somehow manage that configuration and the identity credentials in our service. And to solve that issue, we can use Managed Identity, because it's all about moving the credentials out of your application code configuration files and a service. Second of all, its identity is created and tied to the resource that it was created with. In this case, if we created this virtual machine, as soon as we delete virtual machine, that identity will also be deleted. Third of all, it's as easy as a single command within PowerShell or maybe single click of a button in Azure Portal and you're set up, and it doesn't really incur any additional cost. Third, managed identities are service principals of a special type. So if you already work with Azure AD and you work with service principals, all your scripts will work with managed identities because this is just a service principal like any other. And lastly, I want to mention that its name changed because formerly it was known as Managed Service Identity, in short MSI. If you're gonna be searching for information around this, you might actually find this old name in the blogs, in posts, and maybe in documentation. Let's take then a previous examples that we were talking about connecting two services to each other. In this case, we're gonna have an application on Azure Virtual Machine connecting to a Key Vault service. So a bit more realistic example. In this case, an application will still want to grab a token from Azure AD. When you enable Managed Identity, a locally running internal endpoint will be registered. This endpoint is a small web service running on that virtual machine that is only accessible from within that virtual machine, so only your locally running code can actually request tokens from it. And it does it fairly simple. You just send a token request with no credentials to this endpoint. It will then use the internally stored credentials on that virtual machine to connect to Azure AD, grab a token from it and pass it to your application. From that point onward, it's pretty much the same flow as previously. Token is validated by the service that it was sent to. In case of Key Vault, additional verification like access policy verifications are done. and once everything is okay, a secret or anything that you were requesting from the Key Vault is returned to your application. As you can imagine, we just solved an issue because within our code, we have no credentials anywhere, because that token request that we send to Manage Identity endpoint has no credentials in it. Additionally, one thing to note is that when you register Manage Identity, the name of that identity will be the same as that service, the resource in Azure that was used to create it. So in the case of that virtual machine, the identity will be the same name as the name of virtual machine. And lastly, remember that the lifecycle is tied to that resource. So if you're gonna delete that virtual machine, the identity, the service principal within Azure Active Directory will also be deleted. While this flow looks a bit more complicated, you're still exposed only to 4 steps. So you're sending a request to get a token, and you're using that token to the external service. If you're using SDK, this is super simple and doesn't really require you to do any additional steps. In fact, in my opinion, it's actually easier than using Azure AD out of the box, but we can actually get to that. So what services are supported with Managed Identity? Well, most common services that are used within Azure does actually support it, like virtual machine, app services for your web applications, LogicUps, Data Factory, etc, etc. I have a couple of demos for this today, so let's actually go to Azure portal and start presenting Managed Identity. In my Azure subscription, I have created the resource group Azure Managed Identity Demo. In here, I have couple services because I want to show you a demo which will use pretty much most of them. I will have a demo for LogicUps, Data Factory, and App Service, and I will use Key Vault and Storage Account to perform a demo. So let's do it like this. Let's go to Storage Account. In here, I have a container called Data, and inside of that container, I have a car CSV file that we'll be accessing using Managed Identity later on in the demo using Data Factory. But for now, what I need is in the access key section, I will copy a connection string to the storage account and I will put it in my Key Vault. So let's go to Azure portal, let's navigate to Azure Key Vault. In here, let's create new secret in a secrets blade, hit generate or import, let's call it storage and enter the value, which is our connection string, and hit create. We're gonna use this for all of the other examples, for all the demos, retrieving that secret using Managed Identity. Which brings us to the first demo. Let's go to LogicUp and start creating Managed Identity here. In most cases, you just need to navigate to the overview panel, and on the left hand side in most services you will find Identity Blade. When you press on it, it will allow you to create Managed Identity. On the top you have two options. You have System Assigned or User Assigned. I will talk about this a little bit later, but for now, let's create a System Assigned. System Assigned in short is Microsoft Azure will tie it to this service directly, so an identity will be tied to this LogicUp. So let's hit on and select save. Hit yes, and this will enable identity for this LogicUp. Once the identity is enabled, you can start actually using it. It will give you a brief information what is the object ID, which is also often known as a principal ID. And you can use this in your scripts, but you can also use the name. So I'm gonna actually copy the name of my LogicUp and go to Key Vault. Inside of Key Vault, I will open this in a separate tab. In Access Policies, you need to give access to this LogicUp, to this identity that you created. Because as you remember, besides token verification, it will verify the access policies. So you need to go to Add Access Policy and select Configuration. I personally don't use the templates. I usually handpick the permissions that I only need. In this case, I want to get and list the secrets. I then need to select a principal. As I said, Managed Identity is just a principal, so you just need to provide the name. And you will be able to find that principal by the name of the LogicUp that it was enabled on. Select it, click Select, hit Add, and remember to hit Save on the top here. Once your identity has been added to Access Policy, you can go back to your LogicUp and start creating the flow that will use it in order to connect to the Key Vault. In this case, I will start from a simple HTTP request, and I will create a small again HTTP request to a Key Vault. Azure LogicUps support managed identities in the so-called HTTP action block. So when you create it, select action HTTP, you are able to send HTTP requests within LogicUp. And you can actually select methods. In this case, I want to retrieve a secret from a Key Vault, which is the method get. Second of all, what I need to do here is get the URI to our secret. To do so, you need to go to Key Vault, navigate to secrets, select your secret, select on the current version, and grab the URL here from the secret identifier. You can then paste this URI to your HTTP request. Notice at the end you have the name of the secret, but additionally you have the version. If you want to retrieve the current, always up-to-date secret, just remove this version from the end. And additionally, you need to paste here the version of the API that you're connecting to. From the documentation you can read the current version is API version 7.0. And once you have this request, the only step that you need to perform right now is add here an authentication on the bottom. In the authentication, when you select it, a new option will appear, authentication type, which will allow you to select manage identity from the dropdown. And as you see here, we can again choose what kind of manage identity we have enabled on this service. In this case, we enabled system assigned manage identity and give an audience. An audience is a security feature for the token. So you're telling Azure AD to which service I will be using the token to. So in this case, it's an Azure Key Vault. So Azure Key Vault has an audience of vault.azure.net. It's pretty much the URL here on the top that you use to connect to. Once you do that, simply hit save and you can run the LogicUp. After just few seconds LogicUp run, you can open HTTP action to review the result. And as you see, the value is pretty much our connection string that we saved within the Key Vault. And that's pretty much it. This is how easily you can actually use manage identity within LogicUps. So let's go to the second demo. In this demo, I'm gonna use Azure Data Factory, one of the most common services when moving data in Azure. In here, I will navigate to Data Factory, open Author and Monitor to open Data Factory Editor. And in Data Factory, I will actually create new connectivity to Key Vault. Interesting fact is that by default, when you create Data Factory, it already registers a manage identity for it. So you don't actually have to press anything, you don't have to click anything. It's actually already there. So you just need to grab the name of Data Factory from your Azure portal and go to your Key Vault. And again, grant an access policy so that Data Factory can read data out of Key Vault. So add an access policy. Again, choose the permissions. In this case, I just want to manage and list secrets. Select the principal, paste the name of Data Factory. And as you see, there's a principal like that here. You can select it, hit add, and remember to hit save. Now both LogicUp and Data Factory can connect here and read the secrets of this Key Vault. That means if we navigate back to Data Factory, we can actually go to Author tab, and at the bottom you can find connections. In here, you can define new connection to Azure Key Vault by pressing New, typing key. You're gonna find Azure Key Vault, hit continue. You can change the name, but what you need to do right now is to select your Azure subscription and select Azure Key Vault that you're connecting to. Notice by default it actually says here manage identity name, giving you the name to copy. It also gives you manage identity object ID, but also there's a small shortcut that if you press it, it will open a blade in the Key Vault for you to be able to add access policy very quickly. So it's just a small shortcut. Once you do it and everything works fine, you can simply press test connection. As you see, connection was successful using this manage identity. So let's hit and create this connectivity. So how do you verify this actually works very well? What you can also do is you can hit new and create Blob storage connectivity using this Key Vault as a backend to store the connection string. Let's select continue, and in here we need to change from connection string to Azure Key Vault and select our Key Vault link service that we just created and provide the name. In our case, this was storage. Leave the secret version because we want to grab the latest version of our secret and just press test connection. As you see, the connection is successful. Therefore, our managed identity connection to the Azure Key Vault and grabbing the secret, which is our connection string to the blob storage, works very well, and that was fairly simple. So where are all those internal endpoints that I was talking about? I started from the simplest service because in those, these endpoints are hidden because of the features that those services provide. So the more platform as a service, the more mature services that you use, the less you're gonna actually see managed identity in action, although you can still leverage it if you're building applications that use code, like the one we're gonna have in a second on Azure App Service, in which you actually have to be aware that this endpoint exists and how to use it. To finish the demo with Data Factory, let's actually create that link service. Let's very quickly create a small data set on the blob storage. Select a CSV file since we have that car CSV on our blob storage. Select the link service that we just created. Select the file path. If you hit browse and it connects successfully to blob storage, you're gonna see your data container and car CSV. Hit OK. Select first row as headers. Hit OK. And now we created a dataset that connects to blob storage using the secret stored in Azure Key Vault and Managed Identity to connect to that Key Vault. If you open Connectivity tab here, you can actually hit Preview Data to see that everything works correctly and fine. One additional thing that I want to show you is that actually Azure Data Factory with its Managed Identity can also connect to blob storage without actually need to use that connection string in Azure Key Vault. To do that, we first need to grab this identity and grant an access to Azure Blob Storage. Let's go back to Azure Portal and open our storage account. In here, we need to go to Access Control Blade, hit Add, New Role Assignment, select a role. And in order to be able to use Managed Identity with Azure Blob Storage, you need to grant it a role from RBAC. And RBAC roles that allow you to read data of blob storage are called storage blob data and the name of a role, like reader. Then you need to search for your identity, select it, hit save, and as you see, adding role assignment. From this point onward, Azure Data Factory can use this identity to connect to blob storage directly. So if you go back to Data Factory, if you go to Connections, you can actually go to Azure Blob Storage Connectivity and change the connection from the account key to Manage Identity. Then you select the subscription, select the storage account name, and test the connectivity. If you get error while connecting, this is normal, because if you do it as fast as I do, the permissions didn't have chance yet to apply, so just give it a minute or two and it's gonna be okay. And as you see, after 2-3 minutes, your connection will be successful without doing anything else. With that said, you can use Managed Identity in a very simple manner using most of the services in Azure. If you hit Apply now, if you go back to your dataset and preview the data, notice that you are now able again to read the data. This time, it's not using connection string stored in Key Vault, this time it's using Managed Identity to connect directly to blob storage. Now let's actually move back to Azure Portal. We can close Data Factory for now. And let's create our third demo using Azure App Service. For Azure App Service, I want to show you a simple web application that will be reading also a secret out of this Key Vault. To do that, let's go to Azure App Service. Again, on the left-hand side, let's find Identity Blade and let's enable Manage Identity. Let's hit Save and let it run for just a couple of seconds. Now that we enabled Manage Identity, we can grab the name of our resource and go back to Key Vault. Inside of the Key Vault, we again need to grant an access policy so that this identity can connect and retrieve our secret. So let's select Get and List Permissions, select the principal, search for our principal for the app service that we just enabled, select it, hit select, add it, and remember to press save. Now our Key Vault will grant an access to app service. So how do we validate whenever this app service has the proper access assigned? So let's go back to our app service, and on the left hand side you're gonna find something called Advanced Tools, also known as Kudu. If you open this, hit go, this allows you to review what is happening on Azure App Service from the browser window. Hit Debug Console, select PowerShell, and I already have prepared a script for you that you can actually validate whenever Managed Identity has been enabled properly, and it runs in PowerShell. Let me paste in the script here, and as you see, first of all, it picks an API version, resource URI, the same as in Azure LogicUps, we're picking vault-azure.net, MSI endpoint variable, and a specific URL that needs to be combined to use this internal endpoint. And then we're just doing get request and displaying the access token on our. And after we run it, we should see our token on the screen displayed. And this MSI endpoint variable that I was showing you is a simply set an environment variable on this service, and it points to local endpoint for Managed Identity. As you see, it's still the old name, MSI, but it allows you to bring the tokens using the code. Since we know the Managed Identity is enabled properly, let's talk about how we can now develop the web application that will use this Managed Identity and connect to Key Vault to retrieve a secret. And one thing that might have crossed your mind already is how you're gonna develop the application locally if this is Managed Identity and it's only enabled on Azure service. So when it comes to local development, what will happen is instead of virtual machine, you'll be running your application on your local machine. And instead of Managed Identity endpoint, what you need to have is you need to have Azure CLI installed. And all the SDKs, if you're gonna use them, they will use by default when you try to access Managed Identity endpoint and it's not found, they will use Azure CLI to get the token. Therefore, you just log in your session in Azure CLI and the SDK will do everything for you. You don't actually have to change anything at all in your code to develop locally. That said, let's actually move to Visual Studio Code and run this demo. Inside of Visual Studio Code, I will create new web API application using .NET New. And additionally, I will add the two packages that are required to work with MSI. First one is Microsoft Azure Services App Authentication package. And the second is package that is required to work with a Key Vault, which is Microsoft Azure Key Vault. Once you add those two packages, you can actually start changing your code to work with Azure. One thing to note, it's worth checking whenever you're already logged in into Azure CLI by typing az account show. If you're already logged in like me, you can start using this to perform Key Vault authentication. One thing to note is that the account that you're using in CLI, make sure that inside of the Key Vault, this account has an access to Azure Key Vault. Since I'm using my personal account in this session, then I already have an access because I was the one who created the Key Vault, and as such by default I got the proper permissions to see and manage all the secrets. So for this demo, let's create a new controller called secret controller and paste a small empty template. As you see, this is a separate controller. It has a standard constructor and simple get method, which returns an empty string right now. And to get the secret out of Key Vault, we'll literally need 3 lines of code. The first one is we need Azure Service Token Provider, which will be used to instantiate new client for the Key Vault by passing the authentication callback and using our Service Token Provider. And the third line that we need is actually the line that will get the secret from the Key Vault. Since we have now the Key Vault created, the Key Vault client here, we use getSecretAsync method and pass the base URL to our Key Vault and a secret name. In order to get the base URL, you go back to Azure Portal, you go to Overview, and you can actually grab this URL from here. This is the DNS name for your service, and you paste it here. Let's actually remove this as some enter has been passed, and now we need to pass the secret name. I already know it's called storage. and simply, once you get it, return that value. You can save this and press F5 to start initialization of .NET-based project in Visual Studio Code. Once you press it, it's gonna add some standard files to your project. Then again, you can close this and press F5 again to start debugging session. What you're gonna first start is that we actually added some extra lines of code, but we never included those namespaces. And to fix those assembly errors missing, just add usings for the packages that we included in our project, the Key Vault and Services App Authentication, which should fix all the issues here. Then again press F5 to run the code and run the local debugging session. Once the code runs successfully, remember this is one API, so you're just gonna get 404 error because there's no home page. But what you can do is type /secret and you should get the secret out of your Azure Key Vault. And as you see, this is our connection string that we stored in Azure Key Vault. And we didn't use manage identity in this case because we used local CLI, but we created a very simple, very neat code that doesn't have to be changed. And to prove that to you, I can actually now close this, stop this application and deploy this to Azure. So simply go to Azure extension on the left-hand side here. If you're already logged in, it will list all the app services within your subscription. You can select the app service that is already there, right-click on it and hit Deploy to Web App and select your project. Add a config to deploy, hit Deploy to ensure that you're overriding what is currently there, and let it run. After just a couple of seconds, the application will be built, sent off to Azure App Service, and this API will be available from that URL for you to use. But the difference is, without changing a single line of code, we are able to leverage Manage Identity to connect to Key Vault using Azure App Service and this SDK for .NET. As you see the deployment completed, you can hit Browse the website, open, and as you see now the URL is no longer localhost, it's our app service within Azure, and just type /secret. And in this case, we're using Manage Identity to get the same result. This is how you develop locally using Manage Identity and then deploy to Azure using the same line of code. But notice that it's really simple when using SDK, and SDK is already available for pretty much most of the languages like Java, .NET, and other like Node, etc, etc. So make sure to take advantage of those. So what are additional features that you get when developing using Manage Identity? Like for instance, being able to pass the firewalls. If you're using Manage Identity, using services like Data Factory, LogicUp, etc, etc, and connecting to other services that have firewall settings, like for instance, storage account. There's a checkbox that allows you to enable firewall exception for trusted service. And in Azure, few of the services are considered trusted when they are using Manage Identity for authentication purposes. Therefore, they will be able to pass the firewall without needing to install any gateways. And second of all, we were using something called System Assigned Identities, but there's also a second type, which is User Assigned Identity. The difference here is that User Assigned Identity is a separate resource and the identity is tied to that resource, and that User Assigned Identity then can be tied to multiple services. If you go to Azure Portal and you want to create User Assigned Identity, just go to Create Resource, type User Assigned, and you're gonna find User Assigned Manage Identity, hit Create. It's just a resource like I said. I'm gonna call it AM Demo, select the resource group that you're working in, hit Create. This will now create a resource and tie the Manage Identity to that specific resource. Once the Manage Identity is created, you can go to your resource group and see it there and use it as a normal resource. Once it's there, you can actually grab this name and start assigning the permissions, like by going to Key Vault and the same as previously, going to Access Policies to grant it privileges over the secrets. Get and list, select the principal, and find the User Assigned Identity here as the service principal. So as you see, everything here is still the same. The difference is how you use this Manage Identity, because this is a separate resource. So let's grab our first example of Azure LogicUp. If you go here to Identity, you can actually change from System Assigned to User Assigned and hit Add. It will allow you to select identities found in your Azure subscription and hit Add. As you see, the error is that you cannot mix the two. So you cannot have system and user assigned identity on a single LogicUp. So the first thing you need to do is to disable this, hit Save. Once the system assigned identity is disabled, go to user assigned, hit Add, select your identity, hit Add again, and it added successfully. As you see, the Add button is still here because you can actually have more user-assigned identities to use within your LogicUp. And once you do it, you simply go to LogicUp Designer, to your HTTP request, and change the dropdown for the Manage Identity and select AM Demo. Once you save it and that identity has privileges to a Key Vault, you can run this to see the successful result. And you can review that we were able to retrieve connection string from Azure Key Vault by using user-assigned identity. This is a perfect example where you create one single identity, assign all the privileges to it, and let it be shared across multiple resources in Azure. While it has its advantages and disadvantages, it's definitely a nice feature to have here. Managed identities are amazing feature and it allows you to clean up your code, make sure that your applications are secure, and Microsoft invests a lot of time into developing more and more features around them. Definitely worth investing your own time into learning them and applying them in your own solutions. But for today, that's it. If you liked the video, hit thumbs up, leave a comment, suggest me some video ideas, leave a feedback, and subscribe, because definitely I'm gonna see you next time.